Hi everyone, hope you are doing great. Today we are going to explore Turtles module in Python. Turtle is a graphics module. It's a simple graphics module, and there are multiple classes exposed. And we can find the documentation in this link docs.python.org and Turtle, and we can search for Turtle. And today we will explore this module by dealing with certain simple challenges like showing the turtle on the screen and moving the turtle forward and making a square, dashed lines, um, spirograph, and multiple other things. So let's get started. I have opened up the Visual Studio Code and I am creating a new file. I will name it as turtle part1.py. And so in order to work with turtle, first we need to import that module. So we will import turtle module as t. So I am giving an alias name as t. um, so the turtle is one of these standard libraries that comes with the Python installation. So we need not install it separately, and it would be already available with the Python installation. So we can directly import the package, import turtle as t, and now we can uh, here we can actually create a object, turtle object. Now I will name my turtle object as team. Team is equal to t dot. I'm creating using the turtle class to create this turtle object. And we can actually try and print this turtle on the screen. Before that, we will actually try to create a screen. So we are going to create a screen object by using the screen class of turtle module, and we are going to close the screen on exit on click. So when we click on that, then it will actually exit. So now if we run our code, so this is our turtle and it is currently very small, so we are unable to see it clearly. And and this is the screen and Python turtle graphic screen, and we can click on it to close that. So now we will try and actually give a shape to our turtle. uh, for that we will be using the shape module that came with the turtle graphics, and we can actually give the uh, string name, what shape we need to have it, and we will try to print it. So now we can see our turtle appearing on the screen in the shape of a turtle. By default it will appear in the middle of the screen. So now we will try and draw a line using our turtle, and we can even change the color of our turtle. So we will try and change the color of our turtle to green. So now the turtle is in green color, and if we want it to be red, we can change it to red, and so on and so forth. We can also change the outline color and give a different uh, inline color. So if we run this one, you can see that the outline color is red and the inside color is green for the turtle. Now we will try to draw a line using our turtle by moving the turtle forward uh, by say 50 um, 50 characters or 50 spaces. So it moved forward by 50 spaces. Since the outline color is red, it has used the same for drawing the line. Now we will try and um, draw a dashed line uh, by using our turtle. For that, we can look at the documentation to see if we can use um, any of the classes or methods that are present. So here we can see the turtle methods that helps in move and draw, and then we have turtle state, setting, and pen control. There we have pen up and pen down, which we can use to actually draw a dashed line. So for that we will do what we need to do is, uh, for moving forward by 50, we can actually we can move 10 spaces forward, and then we can do a pen up, and then move forward by another 10 spaces, then do pen down. Now if we actually kind of loop through these 4 steps, say, then we will have our dashed line. We can see that it's going out of the screen because the range that we chose is 100, and that is the reason. For each 100, for 100 it is moving forward by 20 spaces, so 20 into 100 is 200, and since the screen is not that big, it is moving out. So we can adjust this to keep it inside the screen. There we go, we have a dashed line created. So now we will try and draw a square using our turtle. So for drawing a square, uh, we need to actually shift our turtle uh, up or down by 90 degrees angle, and then we need to further move forward. So for that we will probably go over the documentation once to see if there is something that we can use. So if we see here, we have a right or left, and if you look at the documentation for uh, right or left, it shows like we have to give the angle that in the turtle has to shift um, by when we uh, invoke that method. So the method has the parameter of angle that needs to be passed in. So we will try that out. So we are trying to move forward by say 10 or 15, and then we are going to turn say left by 90, and we can probably just run and see what it is doing at this point. So it has moved forward by 15, and then it has turned towards right left. So after this it has to move forward again. So 15 is very small length, so we will bump it up to 50, and we will actually do the loop through this for all the sides of the square, which is 4. So now we are trying to run our code, and it has thrown an error because of a typo. There we go. So we are able to draw a square successfully with using our turtle graphics. Um, Now we will try and and draw different shapes using our turtle. So, this is for drawing different shapes. We know that for drawing each shape we have to actually go with a specific angle. So we have to figure out what that angle is. So for example, if we look at a triangle, then it's if we look at a uniform or equilateral triangle, then we need to shift our turtle by 360 divided by 3, and which would be like 120. So we can try that first to see if we can print a triangle first. So we are able to create print a equilateral triangle, and what we understood is if we actually print if we actually traverse by 120 degrees, which is 360 divided by 3, that is overall 360 degrees is the complete angle, and out of that we are trying to make three sides. So that's why we are dividing 360 by 3 to create a triangle. Let's see if that logic holds good for square as well. So now we will try to create a triangle overlapped with a square, overlapped with a pentagon and hexagon, and we will go till the decagon. So for that, and just to make it more better, we will try and use different color each time. To use a random color, we will import the random module as well, and we will use the color mode of 255 for our title module. So if we need to know more about this module, we can actually get to the documentation and look at the color module. So the color mode will actually define in what is the color range that we are going to use in our module, and this range is for the RGB values, which is red, green, and blue values, and every color can be defined based on a combination of random values of red, green, and blue. So, for example, if we look at this color of 240, 160, 80, it will give a specific color, and if we have 255 for all red, green, and blue, then it would be a white color. So, and in similar lines, 000 would be a black color. So we would try and use different random colors. For that, we will quickly check whether it will work as such. So as we discussed, like when we used 0, 0, and 0, the combination has resulted in a black color. So we can now try and generate a random color out of this uh, um, by manipulating different values for red, green and blue. We will try that now. We will try and come up with a function that would actually return a random color combination. For that we will be using the random module and randint, which would actually give a value between 1 and 255. So for red we got a random value, and in similar lines for blue we got a random value, and for for green and blue also we are getting random values, and this we will return a tuple having the random values for red, green and blue, and we will use the same every time we go we draw our shape. We will use that. So we will define a another function for drawing a shape based on the number of the sides. So the function will draw shape based on the number of sides, and we will put this entire logic inside this function, and we are going to use the sides that we get from in the function call. And every time we will change the color for Tim to with the random color combination. Now we will try to call this function with different values or sides. So as we see, we can see multiple different shapes getting drawn, and and we are drawing for the sides from 3 to 10. So let me increase the length so that we can look it better. So the first one is a triangle, then followed by a square, then a pentagon and a hexagon, and now it is heptagon and octagon and nonagon and decagon. So our turtle has drawn all the different shapes. So for this we have used the random module, and for shifting the colors we have used um, the random the color mode for the turtle module, and also the random um, randint method for random module, and so on. So hope this gave a good understanding about the turtle modules, and this is a cool module which can be further explored, and we can build multiple uh, fun games through this. Now we will also do try and do a random walk. Random walk is something like uh, when the turtle goes in multiple directions in a random pace with the different colors. So for that, what we will do is, let me just quickly comment out all this code for the size. And now we will still use the random color, and we will actually use we need the turtle to go in multiple directions in a random pace. So let us come up, we will add a new list called directions, and here we will actually specify the angles, like 0 angle, 90 degrees, 180 degrees, 270 degrees. So these are the four different angles for through which it can change its direction. So now we will quickly check in the documentation, is there anything that we can use for the for our purpose. So here we see something called set heading. So this set heading is a method that will take um, the angle to change the direction of the turtle. So we can use this particular um, method to accomplish our task. So now we will actually try and move our turtle for, we will try for 20 occurrences first, how it moves. So we are going to dot color of random color dot set heading, and we are going to use random dot choice of directions, so that it will actually choose one of the four values randomly, and then we will move team forward by 15. Let's see how this works so far. So the team is doing a random walk. It went through multiple directions. So now we will try and make its uh, the lines more thicker. For that, we can see what we can use here. Um, so here we can actually see something like pen size, uh, which will actually which can be used for increasing the size of the pen. So let's use that. We will set a pen size of say 5, and also we will try and make the our team move faster. For that, there is a function method called speed, which will have a parameter of 0 to 10, and 10 is the fastest. Also it accepts the four different strings. So if we look at speed, it accepts the first different strings like fastest, fast, normal, slow, slowest. So we are using fastest, and now we will just quickly rerun our code to see how it works. Yeah, now let us increase our count to say 100 to see the random walk. Great. We can even bump it up a little bit more. Awesome. So this way we can actually do a random walk with the help of team. So now I will go back to the pen size. So now we will just try and draw a spirograph. For that, we will define a function by name spirograph. Spirograph is a group of circles. First, we will try to see how to draw a circle using the um, documentation. So circle will we can just use a radius and it's a straightforward way. So let us just try and draw a circle. Team dot circle of say 20 and maybe we will draw a bigger circle. There we go. So now we will try and move the team around and try and draw another circle. So we are able to draw multiple circles with this approach. So now we can come up with our logic of drawing a spirograph. So draw spirograph, and we will probably give the gap amount as a parameter into our function. So we will every time we will also set a random color. So now we have run come up with a logic for drawing this paragraph, and what we are trying to do here is we are shifting the circle by a specific angle, and we are trying to go through all the entire 360 degrees angle. So that way we are trying to complete that 360 degrees angle, and that's why we are looping through in a range of 360 divided by the gap amount. And while we are doing that, since 360 divided by gap will return a float and range doesn't accept float, we are trying to change the type from float to int. So let's try and run this. we I never called the function, so let me call the function as well. There is an error. Yeah, I missed to send the gap, which is we will try with the 5 degrees angle shift. There we go. Yep, this is where we are able to draw a beautiful spirograph, and we can even hide our turtle to show it, uh, make it look better. Tim dot hide turtle by using the tim dot hide turtle method. Trying to run again. There we go. Awesome. So this way we are able to achieve drawing a paragraph, and we can even make it change the gap to 10 and look how it looks. It would be looking. So 10 looks even better. So this way we can draw cool graphics using the turtle module. Now as a last trial, we will just try to draw a painting using our um, painting of dots using our turtle. So we will try to actually move the position, change the position, and try to come up with a simple painting with a color dots. So let us first um, we set the position for our turtle. Team dot set position of, we will try to set it at minus 240 and minus 240. The x coordinate as minus 240 and minus 240, and then we will try to add a dot with the size of 20, and then try to move him forward by 10, and again we will we will see how it's going on till now. Let's run our code. Let me check. So it threw an error, and it says it's a typo from my end. So let me fix that. Okay, so we are able to change the position and print a dot, and move forward by 10. Okay, I think I need to move forward probably by 50 to actually see the dot separated out. Okay, so now we will we'll actually take up the pen, like, so that we don't see these lines, and we will change the color, and we will come up with a simple painting. So for that, I'm going to draw a row of 10 dots with the different colors, and we are going to further draw around uh, 10 rows like that, so that it would look like a beautiful painting. So for that, I'm going to arrive at a row function, draw row, and in that I'm going to just I'm going to put this before, and move this to right. And also we'll use different color every time, so we'll call our random color function. And as we thought, like we are supposed to we will do our pen up so that it won't actually the lines won't appear. And also after the dot, uh, before moving forward, also we will do pen up. So since I have moved the pen up and I have never put the pen down again, though it occurred multiple times, it did not work out, so I will just put the pen down here. For time being, I will try and just remove the pen ups, and yeah. So as usual, I missed to call this function, so let me call the function. So we are able to get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 dots of different colors. Now we will loop this through for 10 times. But when we are looping it, we are going to make sure that for the second time, the next time it runs, we are positioning, we are setting team's Y position, set Y uh, to current team's Y position, plus 50 and set x to minus 240. Now we will see how it goes. That's it. So we are able to come up with a simple dot painting with the different colors separated evenly and with 10 rows and 10 columns. So hope you guys enjoyed this video, and this would have given an initial understanding of how the turtle graphics work. And this is a simple turtle module which illustrates the uses of objects and methods and attributes. So using the documentation available, we can quickly explore and draw cool graphics using the title graphics module of Python. So hope you enjoyed this video. If you like, please subscribe to my channel and share and like the video. Thank you. Have a good day.